look like you have computers.
Sometimes I like go to this
Most
one.
of the code is in a GitHub, which I'll show you once the video gets connected. And if you don't have a bunch of stuff set up on your computer to work with D3, JavaScript, Node, I'll be using this browser-based tool. So as long as you have a web browser, ideally Chrome or Firefox, you should be able to follow along interactively. And yeah, we're just figuring out some video things, but we'll get started in just a second here.
Good afternoon, everyone. Sorry for the delay. Welcome to Open Data Science Conference, San Francisco. Thank you, Jonathan, for agreeing to host this workshop. Just going to introduce Jonathan, and then I'm going to open the podium for him. Jonathan is currently the VP of Academic Excellence at Galvanize. Previously, he founded Zipfian Academy, which recently has been acquired by Galvanize. He first discovered his love for all things data while studying computer science and physics at UC Berkeley. In his former life, he worked for Alpine Data Labs, developing distributed machine learning algorithms for predictive analytics on Hadoop. Jonathan has always had a passion for sharing things he's learned in the most creative ways he can. At Galvanize, he gets to combine his two favorite things, humans and code. When he's not working with students, you can find him blogging at About Data, Visualization, and Education at hopelessoptimism.com. Thank you, Jonathan. Welcome.
Thanks for the intro. I think that was the first intro I ever got at a conference, which is exciting. Thank you, Open Data Science Conference. There's lots of people here I've never presented to this many, and this many that all have computers and are ready to just dive into code, so I'm pumped. As you heard, I am the VP of Academic Excellence at Galvanize. On Twitter, @ClearSpandex. That's actually the best way to get in touch with me. If you do have any cool data viz, if you want to chat about a project, if you're just like, hey, check this out, @ClearSpandex on Twitter, best way to get in touch with me. These links at the top are going to be two of the main resources. The first one is actually a forum chat room. It's called, it's a service called Gitter that basically works with GitHub repos and is basically like IRC chat. So if you do have any problems during, after, whenever you're going through the resources, definitely use that Gitter chat room to stay in touch about the materials. The GitHub here is github.com/j-o-n/interactive-data-viz. So that's where all the examples and all the solutions are going to be. So if you do have a computer, if you go to that GitHub, you can see all the materials, and I'll show in just a second this browser-based tool. So if you don't want to clone the GitHub repo and have all the data on your laptop and try to configure servers and whatnot, I'll be mainly using this tool to interactively go through a lot of the examples. And as you heard, Zipfian Academy was a data science school that I founded. It is still, as part of Galvanize, a 12-week full-time data science immersive. And it's really geared towards helping people bridge the gap from school or another career into the data science industry and helping students become practitioners. So if you are interested in machine learning, statistics, analytics, and you want to dive deeper into all this stuff, definitely talk to me after. I'm happy to tell you about the programs. We also just launched a data engineering course if you are coming from distributed systems and Java and want to build scalable pipelines. The data engineering immersive is our newest. And the exciting thing of being part of Galvanize is that we also, Galvanize has a full stack 6-month web development immersive geared towards getting people into industry as developers and software engineers. So we try to have accessible on-ramps for everyone, no matter what their background is. So if you're interested in learning more, come chat after. And my whole kind of like formal data viz career kind of got started with this course that was on Udacity, a lot of the materials that I'll be going through now have similar concepts taught through videos in this Udacity course. So if you do want to go back and learn more about D3, data visualization, more of the formal theory, we do have a class. It's free. Sometimes the button to access the free materials is hidden under Udacity's marketing, but all of the videos and materials are freely available online, and it's about 5 hours of video, so I can only cover so much in this session, and if you want to learn more, I'll have a link here in the presentation. So that's kind of all the setup. I'll give a brief overview of what we're going to work through, and then we can dive right into the D3 code. I always like to get a sense of the audience before, though, but who here is a JavaScript programmer, front-end, back-end, web developer? Who here is a data scientist or data engineer? Sweet. Who here has done D3 before? Awesome. So just kind of context of what we'll be working through. You don't have to have D3 experience to follow along or to get a lot out of this. It's assuming no D3 background, but it is assuming general programming and JavaScript background. So I'm not going to go through JavaScript 101, but I will explain a lot of the quirks of D3. So it seems like the audience is at a good level. Here are kind of the 5 bullet points that I'll be coming back to over and over again in the presentation. And the first is just why data visualization? Why do we even do this? How can we leverage data visualization and, in the context of this talk, really empower people for civic engagement? The second one, this is something that's more nuanced than I think people give it credit for, but there's many different avenues for data visualization and purposes for it. Data science and data scientists aren't necessarily the same as journalists or artists. So I'll try to highlight how we as data scientists can make some complex analyses much more consumable by someone out in the audience. And the last 3 here are tied to the exercises of basic visual theory. What are the concepts we're going to need to know about to design these things in a coherent manner? And what's the process of creating these? And finally, at the end, how can we editorialize our visualizations? How can we impart some of our kind of context and narrative into these things that might be purely built on objective data? So that's what we're going through. Also here, this is focused on D3. Everyone always tends to conflate. If I do data viz, I have to do D3. I have to make it interactive. I have to do it in JavaScript. Even though I will be talking all about D3, D3 is not data viz and data viz is not D3. So let's see where each plays. And then the last thing, the title you saw was a little different than the talk. Speaking with pictures, a lot of how I like to think of visualizations is with some visual vocabulary. Much like there's vocabulary and style to writing narratives in words, we can think about a visual vocabulary using things like colors, circles, shapes, scales to effectively communicate what we might be able to write down with pen and paper, but through images. So without further ado, I will jump to the first example here, or actually talk about a little bit of the resources. So this is the GitHub page. This is where there's a lot of the materials for this workshop, but additional other workshops I've given. So if you look down at the branches, there's other branches of other talks I've given. Definitely, if you're interested, look through the materials. The README has a bunch of descriptions of example visualizations, resources, places to learn more. So if you do want to learn more, definitely look through the README. There's a lot in there. And for this we're going to be using two technologies. The first is this site called blocks.org. Who here has heard of blocks.org? All right, so this is actually probably the best way to actually learn D3, learn about more complicated visualizations, is it's basically a tool, a community that Mike Bostock, the creator of D3, set up, and it lets you render GitHub gists of D3 as visualizations that you can see in your browser without having to download them and spin up your own web server. And the second one, this is actually a new project from Ian Johnson. I'm super excited about this because I teach workshops in data viz, and this is really ideally suited for that. This site is blockbuilder.org, and it extends on this idea of blocks, of having little snippets and example-driven education. And it lets you actually take a block of, if you go here and you say, let's look at this example that Mike Bostock did. If you do want to actually take this and make a remix of it, the blockbuilder.org lets you just change the URL, the same path of, it's Mike Bostock, it's gist 135370. And you instead change it to blockbuilder.org / the same URL. It is going to take you here and basically give you a similar interface, but it's going to let you change things with the code and have it update in real time here. So if we do want to make this, let's say make it green, we get this nice little color picker, and we can make it green. And then if we do want to actually save this back, we can fork this and save it to our own GitHub account. So this is going to be a fun way for us to play around with examples and adapt them and learn along the way. So the main two tools, blockbuilder.org and just general blocks that we can write code and share with. The other great thing about this is you don't need to set up a static web server, you don't need D3 installed with Node, you don't need any server-side stuff. All you need is Chrome, and it just works. And for this example, we're going to start, and I basically made 3 of my own blocks corresponding to the exercises and the solutions. So the way we're going to work through this code, the way we're going to learn, is in this iterative fashion, where I'll talk through a basic template, and then you'll go and adapt it on Block Builder, and then we'll talk through the solution, and then we'll go back and forth here. So if you do go to gist.github.com/j-o-n. These are my gists. They're labeled by their title, Civic Impact Through Data Visualization Exercise 1. If you click on this, you can basically see the code. And if you do want to adapt this in real time, you can just change the URL to blockbuilder.org, and then it's going to be the same path /JON/ the hash to that. And here we can see the visualization. So if you do get to this screen, everything's good. The code has worked. You can go and pop it into full screen to see it. You can click on these links on the side and get it in side-by-side mode. So thumbs up if you got to this page.
So we just have to paste that hash, that's it.
Mm-hmm. Yeah, so it's blockbuilder.org and then /JON, which is my GitHub name, and then / the hash. Probably the best way, now that I think of it.
We go to gist docs.
I can't scroll down to the
Gist docs.
Yeah, I'm on the gist. Where is the hash located?
You can't scroll to this. Are you using Chrome? All right, if this doesn't work for you, if you try refreshing it, if it doesn't work, we can just
refresh what?
the browser.
Oh, yeah.
And if it still doesn't work, it's not a technology that I have the source to. The best would probably be to just download the code locally if this doesn't work. Yeah, so if you do want to go to the chat room, I'll just send the link. So if you do click on this little like green get or chat button, and the other context on this is, as you can see, there's something with price, there's something with San Francisco listings here. We're going to be working through some Airbnb data. And again, the readmes of all of these have the two sites, building blocks and blocks.org. They have the exercises, part 1, solution, part 2, solution, and then the final. And they have the data, which comes from this awesome site called Inside Airbnb. And this is basically a developer who has scraped Airbnb's public listings to basically open up this data to add some context to the debate around how Airbnb is impacting rentals and housing in a bunch of cities. The data we're going to be using, of course, is from San Francisco. So this is a great map, it's a great tool. There is a lot of information here. You can basically interact and select things. And you can hover and you can see a lot of information about Airbnb listings. In here, we'll kind of step through and not necessarily get to as nice of an interactive map, but we'll learn about some of the underlying components and see how we can get close there. So with this listing, or with this visualization, I'm first gonna just go kind of dive into the D3, then we'll take a step back and talk about some of these more visual elements. So for folks who aren't familiar, who haven't done D3 programming before, the name itself, data-driven documents, is something where it's going to allow you to create HTML and SVG elements that depend on some underlying data. Of course, there's underlying data here about these listings, but the main components can be thought of as visual elements and then data elements. So throughout any of these, there's always the visual representation of our data, and then there is the backing data, which we can filter, we can aggregate, we can sort. So to start, we always have to think, where does the data come from, and how do we get the data to our browser? In D3, you can either load in the data to start just as some JSON in your HTML, but more often whenever you're working with any data set that is substantial and interesting, it's usually a very large file that you might want to load into your browser. D3 helps us a lot with this by adding these convenience functions to load in data from an external source. So in here, we have functions to load in CSVs, JSONs, TSVs, and convert a text file into some JSON object. So in here, as you can see, we have D3.csv, and the link is actually hosted on the GitHub page, on GitHub Pages. And in here, I'll talk through a little bit of the structure, but basically loads in the data and calls this function, which is a callback, once the data gets loaded. And this is something that a lot of people get hung up on. In theory, this could be a huge data set that, since the browser is communicating over AJAX, could take a while to load. So we don't want to hang up our browser while it's trying to load this data in. And we pass to it this function to call once all of our data is set up. So in here, load in these listings and call this draw function. And all of the rest of this file is essentially this one draw function here. So this is going to be our entry point to actually getting some interesting things. And in here, we're going to use JavaScript to make these elements on the page.
Just a quick question. So that link, joen.github.io, that takes me to mediator page.
Oh, yeah, so that is, you have to go to the /interactive-data-viz. So if you go to jon.github.io/interactive-data-viz, it shows you what's in the repo. jon.github.io is just my general GitHub Pages account across all the repos. So if you do want the visualization repo, you have to go to /interactive-data-viz. And if you are here, you can actually look at all of the code by just referencing the files. So if we want to look at example 1, we're going to look at exercise 1, we can go on the GitHub Pages. So if you do just want to interact with it statically, you can go on the GitHub Pages. But if you do want to play around and actually adapt things, Block Builder is the place to go. So here, this is just convenience functions. You have to load your data externally. It makes an AJAX request. And once it gets it in the page, or once it loads the data, we have access to it in our function. So we say, what do we want to do and manipulate with this data here? And how do we visually want to represent it? So you often, I often think whenever I get a new data set, for reference, for reference, the data here, I don't know, this is not super clear. Anyways, I just want to talk through some of the titles. We have the name of an Airbnb listing, we have the host ID, we have the host name, we have things like neighborhood, latitude, longitude, room type, price, basically anything you can see publicly on Airbnb, we have here. So we have a bunch of these columns, and we often have to think, one, what do we want to visualize, and how might we visualize that? In this case, we're comparing number of reviews on the X to however many days they're available throughout the year. The interesting thing here, you can see if there is a listing that has, let's say, more than 150 or 120 days available during the year, it's somewhat unlikely that someone actually lives there. If they have their house up for more than half the year as a rental, may not be something that they're actually living in, which is an interesting concept and really throws into question whether or not it's just a hotel or whether it's something where they're actually on vacation. So that's what we're going to pull out here is how do things like number of reviews, price change based on days available during the year? Are apartments that are available more actually something where people stay at them more based on the number of reviews here? So we can ask all these interesting questions. And also to show you what this looks like once we get in the code. So I'm going to be going through and using the Chrome debugger here. So pausing execution on the page once it loads, we can see here where in the draw function, the same thing happened as before. We loaded this data, we're in our draw function. We have all of our data as this array of a bunch of JSON objects. So what happens when we actually use D3.csv, when we use D3.json, we convert rows and columns into some JavaScript native data structure. In this case, an array of a bunch of these objects where the keys are going to correspond to our columns. So again, we have all this interesting data. How might we want to represent this? And how might we think about visual elements in terms of color, X position, Y position, shape, and so forth? For the sake of simplicity, let's just make a basic scatter plot based on, let's say, days available and the number of reviews. So we have something for our X coordinate, we have something for a Y coordinate. Let's make a scatter plot so we have a circle shape. And the code in here at the beginning is a bunch of setup. So with D3, you have some scaffolding code that you need to write, mainly because D3 lives at a bit lower level than a charting library. So many people think, well, D3, you make all these awesome visualizations, where's the .scatterplot function? And they learn that you have to do all this code, and they get discouraged. But with flexibility and power comes a little bit more verbosity. So we're giving up the convenience of pre-baked charts, and we're going to get to do some custom stuff. We're going to make some maps, and we're going to have some fun with this. In here, the width and height, we're just setting up to basically be responsive. So if we change our window, we have here inner width and inner height, which just correspond to the viewport window. In these variables, a common convention I use, I just set up a bunch of variables that correspond to the X and the Y field, just so I can quickly change them in one place and not have to change them throughout all the code. Adding a title here, and then adding an SVG element. So the key things in this setup, one, D3 is mainly used to create SVG elements, but you can create anything. You can create HTML, you can create a blog in D3 if you want, and basically template out text with D3. D3 is a way to manipulate elements on the page. So we can manipulate titles. We can also create SVG elements. And from point of note, if you are showing D3 that has SVG elements, you have to put them in SVG tags. So in this case, we have selectors, much like jQuery or other libraries that are coming from things like Backbone and Angular. They also have selectors that follow basic CSS selector syntax. So if I want to actually get the body of my page, I can simply say D3 select body. It gives me this element that corresponds to the body. If I want to add things into the body, I can use append. I can say, let's append an H1 tag. And let's set the text of that h1 tag to be hello world. You can see here, hello world is now in the page. So it's pretty easy to just manipulate static HTML that doesn't really depend on data by using these selects and appends. So the first learning of D3 here is how do I access the thing I want to change and how do I change the thing. So selections are going to be the way to access select body, and we can also do subselects. Let's see if this works. So we can say select body, and then within that body dot select h1. And if we do want to again mutate our h1, let's change it. Hello SF. So that's the basic functionality of how we're going to manipulate the page. And step 2 is actually do this based on data. So we select and we mutate. Any questions on these basic steps of selection and mutation?
So I'm not even sure how you get that interactive part of the model.
Yes. So if you are in Chrome, you do Command Option I, or you go up to the
You're doing this in Block Builder or where you are?
So you can do it in Block Builder. In here, you can do it just as well, and manipulate it. But Block Builder will use for the exercise. So I'm going to be live coding and stepping through each of these, which is why I'm in the console, so I can throw a debugger in. But when we get to the exercise, we're going to adapt this and change the visual elements. So when we're adapting it wholesale, Block Builder is going to be better. For this live coding, I'm just going to go through with the debugger, and then we'll take like a short break to go through you guys manipulating, and then we'll come back.
But we can also run the local web server and edit things.
Mhm.
Okay,
Yeah, so
if
if
you have
you-
options.
Yeah, if you do already have your D3 setup, if you have a local web server, if you do have your text editor, feel free to do that. Mainly using Block Builder just to standardize, because not everybody has those, and to alleviate different operating systems, versions, and so forth. The question, other questions?
So when you do D3 select body, you basically get back a JavaScript object.
Mm-hmm. These are special objects in that they're D3. So these aren't necessarily generic DOM elements. They're basically a bunch of D3 wrapped around DOM elements that have access to all these other functions. So if
can
we,
you print something like the D3 select body select h1?
yeah, so here I'll just, so I'll just save body in a variable.
Mhm.
If you use Chrome's autocomplete and just do period, it should come up with all these things you can call. In here, we have all of the other JavaScript things that we know and love, but we also have these special things like select, select all, .style, .text. So it basically takes standard DOM elements and adds a bunch of additional functions on them.
So what does it look like? Can you print it or?
Yeah, it looks like this array. It's an array with a bunch of elements in it. Body here. Body has a bunch of these functions, many of which are going to look like standard DOM functions.
So they're not JavaScript objects, or they are, but special.
They're special JavaScript objects. Yeah, I wouldn't worry too much. I treat them like JavaScript objects, and I just know that there's extra functions. So it's JavaScript objects Cool. So that's the boring stuff. Let's get into the fun stuff now. So here, just appending an SVG element. A lot of the boilerplate here is doing things like set up the width and the height, and also add in this chart element, which is going to be where we throw our objects. This is a convention that a lot of folks who do D3 use. Basically creates this subgroup element in the SVG so that we can adapt and change the chart outside of this global SVG object. And again, boilerplate, I wouldn't worry too much about this. If you do want to adapt it and change it, I can come around and help you. But with any of these objects in D3, you have these attribute setters. So these are, we say get our body, and we say attr. We can basically set any attribute that we would on any HTML element. So we can actually set, let's say, let's change the style. And let's say background color. And let's set it to be red. So the two attribute setters, dot style and then dot attr. Dot style is a shortcut to actually set CSS properties. Dot attr can be used to set things like class and so forth. So now we have body.charts. So select, mutate, style. That's kind of the D3 life cycle. And all of this, hopefully, we're going to get to do with some data. And the data part is where all the magic happens. Here, also note, D3 has some basic manipulation, data manipulation functions. So we have our data here. It's this array of objects. We can do things like filter. We can say data.max, and let's say we want the max of something like price field.
Show how to get the data variable. Sorry, I might have missed it.
Yeah. Oh no, I'll talk about it.
Sorry.
A quirk of loading it externally. So the convention of this function that we create, it takes a single argument that is the data that we load, and the data actually comes from the bottom here. So we say d3.csv, load this URL, and call this function, passing to it as its argument the data that we've loaded. So notice here I'm not actually calling draw, I'm just passing the function definition to it. This loads the data, it calls the draw function with its argument of the data you load, and we can call this anything. So this doesn't have to be called data, this could be called listings, this could be called houses.
Oh, I understand that. I just mean if I put in data, the variable is not defined. Did you show up earlier in the console about how to get that into a local variable, or?
Yes, the other thing, so the reason I have to do this in a debugger, or I want to, is that the data only lives in the scope of this function.
Oh, okay.
So if you do something where you actually run through the debugger,
Oh, okay.
and the chart gets drawn,
Okay.
we no longer have access to data here.
How did you do the debugger? You ran click that arrow.
Yeah, so the debugger works by just clicking line numbers.
Oh, okay.
So in here, You basically click the line number you want to stop, you refresh the page, and it stops there. Let's get to right here. So the next thing, we're gonna actually start drawing some circles. So we can see here, we got our title, we have our data, and we have these manipulation functions. So we can say D3.max. If we want to find the max price, we say we want the max of our data, and the field we want the max of. Again, everything in D3 uses functions for everything. We can use a function that says, give me the max price. And the syntax for this is basically, the first argument is the array or list-like thing that you want to operate on. And the second argument is a function that signals to D3 what you actually want to take the max of, what you actually want to filter on, what you actually want to mutate and manipulate. So in this case, the second function is going to get passed each data point one at a time as its argument. So here, in this typical callback fashion of D3, we say, find the max of our data with this function. The function gets one element of data at a time, and based on what we return from this function is what D3 actually computes the max of. So in this case, we want the max price, so we access the price value from this object, D, and the plus is just to make it into an actual numeric or integer. So when we run D3 max, it's a generic function that we specialize with this callback. We can just as well get things like the
Availability.
let's say number of reviews.
Can you explain the arguments in function? I know I've seen examples of 2 arguments in the anonymous function, but is there more?
Yeah, sometimes you actually want to get the index. So sometimes people do D and I to actually get the index in this big data array. I haven't used more than just those 2. There might be a third that if we go to the D3 docs.
So D3 is expecting a certain function prototype there, essentially?
Mhm.
So, okay, yeah.
By far the most common convention to do any of the visualizations in this workshop, I only use one. I rarely use more unless I'm doing something extra custom. But if you are interested, the D3 wiki has all of the functions and all of the D3 specific things that they add to these HTML objects pretty well documented. So here max takes an array, and it takes this thing accessor, which is our function. And then the accessors can be used in interesting ways depending on the function or the D3 function. So ascending here has A and B, descending has A and B, and there's a lot, so I'm not going to enumerate every possible one, but go to the docs when you are using one that you're not familiar with here.
So what, the doc is a GitHub project also?
The-
doc? D3 doc is a GitHub project?
Oh, so the D3 docs are just in the GitHub wiki. So all of D3, it's open source, it's on GitHub, and the wiki is where all of the documentation lives. So now we have the ability to select elements, mutate elements visually, and also mutate data. So mutate data, mutate visual elements, select visual elements. We're at the point now where we want to combine all of these. So how do we combine data with visual elements? This is by far the hardest thing to wrap your head around in D3. So pay attention closely. It takes a few times to actually make sense of it. D3 is this really awesome API. It's designed beautifully, and one of the things that the creator, Mike Bostock, really set out to do was, how do we not only create visualizations in a different way, but how do we think about visualizations in a different way? And that's where this data binding really comes into play. So to make things dynamic, to make things interactive and able to update on the fly, Mike Bostock, when he designed the language, said, I want this clean separation of visual elements, these are my SVG circles, and my data. But I want a very easy way to combine them and manipulate them. So in this case, the syntax seems a little bit strange. The first thing we do is we want to see if there's any visual elements already on the page, since we might need to update or adapt them. So in this case, there's nothing on our page. We say SVG, so look into this SVG object and select all the circles. So again, of course, there's no circles. D3 comes back and says, you haven't drawn anything. Put some data on the page. The next function, somewhat confusingly, is called .data, and .data does what's called a data join. So this is similar to a SQL join, if any of you are familiar with SQL databases. And the way I like to think about it is that these visual circles are one table in SQL, and the data is a second table. So when you join things, you basically have a common key. So you say, combine table on the left with table on the right, and find when they have overlap and make them into one big table. We don't have tables, we have JavaScript objects. But what .data does is it says, take everything on the left of the function call, so take everything that I selected, and compute this join operation with all of the data I have. So in this case, we have 5,423 data points. The join of this basically says you have 0 circles and 5,423 data points. So you're missing 5,423 things on your page. .data though doesn't actually put any data into our page. It just computes what this difference, what this delta will be. And to actually get things on the page, we have to use this .enter function. And the .enter function is a little bit strange. Why would we need .enter when we know we have nothing on the page? And of course we want to show everything on the page. .enter comes into play when we actually want to do updates. We'll see in the last example, when we already have elements on the page, when we already have a bunch of circles and we want to update them, we can use .enter. But right now we don't have anything, so .enter signals to D3 and it says, find me all of the data points that I need to put on the page, that need to enter the page. There's an equivalent method called .exit, which says, find me all the visual elements that I need to take off the page. Right now, we have everything to be put on. So what .enter returns are all of our data objects. So here, if we look at what .enter returns, it's an array with objects, and these objects have this __ data. And this is where we basically put this JSON into our HTML. This is great. We now have an array of our data, which is kind of where we started, but the special thing about this is that it's tied, or will be tied to the HTML. So the last element of doing this data join is actually doing something with these data points. So to finish it up, to come full circle, we basically say, find me all the circles, find me how many I need to put on the page based on my data. So this says, you need to put all your data on the page because you have no circles. Enter says, create this array with pre-populated data. And then .append says, put new circles on the page for every circle I don't have for my data. You can see here, we now get returned not only an array of a bunch of data objects, we now actually have SVG circle elements. So data binding 101, we have circles on the page. They have data in them. And just to prove it, I'm going to go back to my HTML. I'm going to look in my SVG, and here I have a bunch of circles on my page there.
I just had a question about this select all circle dot data. I was confused that you said it's a join where there's 0 circles. So when you do select all circle dot data data, what is the state of things at that point? Does that mean that you do you know what I mean? It was a little confusing, I thought.
Oh, yeah, so it computes the overlap. Actually, it's confusing enough. I have a slide that explains it much better. Short diversion. So this is data binding in slides. We basically start off, we have SVG, or on your right, we have the elements on our page. And then on the left, we have the data. So here, this is actually using a World Cup data set, but we basically first do .data. So this is what happens after .data. It says, we have an SVG with no circles, and we have these 5,000 data elements. So it basically creates placeholders, and it says, you will need to do something with these 5,000 elements, but I don't know what you want to do yet. You then say, I want to enter, so take those data points and put them in these blue ovals. We get circles, and then do it for everything. So the .data function just says what's on the left and what's on the right, and what's the delta between them the two. It does something similar, I guess, to an outer join. So if we did a match join, it would say nothing. There's no circles, so how can we join them to any data? It actually does something similar to an outer join, and it says, even though there's not anything in here, there's a bunch of data elements, so create these empty rows. These empty
Okay,
placeholders.
that makes more sense now. Thanks.
The order matters in data binding, right? Like,
Mhm. And so here's a fun thing that usually you shouldn't do. But the funnest things you usually shouldn't do. So in here, we can say, here, let me get back to a clean debugger state. So here, we're going to redo this, and we can actually say, I don't want to append circles, I want to append rectangles. So we can select all circles, and then based on the circles, we can actually append rectangles, which is something that, again, you shouldn't do, but you can do. And that kind of just shows this decoupling, because every example out there, 99.9% of the time, what's on the select all before data and what's in the append after data are the same elements. But again, these are totally decoupled. D3 is general enough that you can say, I actually yeah, cool, I'm gonna create elements based on how many circles, but the elements I'm gonna create are totally different.
So then how does it look? How does the page look if you do that?
Well, here we just have a bunch of rectangles. So append is just gonna shove them beneath all the circles.
So you'll have both circles and rectangles at that Oh,
Depending on the order, depending on whether you call enter or you do an update or something. But that's not useful things to do. But again, I just want to show you, hopefully demystify some of the D3 magic. And notice there weren't any circles visually on the page. They were just these empty elements. So the next thing is, how do we actually get something with these circles? The third and last thing that I'll go over with this example before I break and let you guys go through the exercise and try to adapt it is the third really core function of D3. The first core function is manipulate, load, filter data. The second function is data binded to HTML or SVG elements. And then the third function is what I say going from data to pixels. So D3's main heavy lifting function is a way to say I have price which maybe goes from 0 to 10,000 or 50,000. But I only have, let's say, 960 pixels. So how am I going to programmatically draw circles at the right X and Y position based on the data? And the way D3 does this is through scales. And the way scales work is you basically give it your input domain and your output range. So you say, in this case, Y field is the availability, 365. X field is number of reviews. So in here, we're basically going to say we want to create this x-axis. This x-axis is going to depend on the total number of reviews. So first, we actually have to find what is the limits. What's the max number of reviews and what's the minimum number of reviews? That's what this extend function does. Just like max that I showed you, it takes the list or the array as its first argument, and it takes this accessor function as its second. In here, extend actually returns the min and the max. There's also the min function, there's also the max function. So D3 lets us know the limits of our data, and then using this scale, we can actually make that conversion. So it says, create a linear scale. You can have other quadratic scales, other things. Set the input to be this extent. So you basically say dot domain, we're going from 0 to maybe 5,000. And the output range goes from 0 to width. And to give an example of what these scales look like, we have review scale now. Review scale is simply a function, so it's a function that takes inputs and it gives outputs. Let's say 0. Let's say someplace has 0 reviews. What X position do you think 0 corresponds to? 0. What X position, harder question, do you think 600 corresponds to?
so you take the fraction of the output range and the input pixels multiplied by 600.
We don't know. I don't actually know. 600 corresponds to 280. And if we look at what our extent is, review extent says 0 to 336. So giving it 600 is actually off the scale. It's off the charts. It does interesting, strange things. But let's actually give our scale the max, 336.
No, you have to give it the largest number of the thing that has largest, that will give 336, right?
Well, the extent is 336. That's the
Largest.
largest.
Number. Oh, okay.
Yeah, so this is actually, this is correct. Early on, if you've been listening, I said I made this super responsive. So this is actually only 157 pixels of screen since the debugger is taking up everything. A fun interactive demo. Let's see if this actually works.
I think properly loaded.
Yeah. Yeah. The width, your width is old.
Anyways, yeah, we can do fun stuff with the widths, make it super responsive, but again, we're not making responsive stuff. We're just making things. So going back, we have these functions that, as input, take our data and they make this mapping. They say you go from 0 to 336, and you only have 157 pixels. You have 960 pixels. So let's take that point, find out where proportionally it is, and give us a pixel value back. So this is going to enable us to actually programmatically generate X and Y positions pretty effortlessly. In here, I do the same for the Y-axis. The functionality is pretty much the same. Nothing too exciting there. There's also a lot of boilerplate to just add axis titles. Again, I'll leave the boilerplate there, and we're not going to need to change and manipulate it. But I quickly wanted to finish up with the fourth key function of what we need to do to get circles. So we selected our elements, we added our data, we built our scales, and now we actually need to do something. It's been blank. We've been writing code, but nothing is showing up. So how do we make things show up? In here, we are going to use everything that we knew and loved from the beginning of the workshop. So we have these .attrs. So in this case, if we go to this point, we have these .attrs, which are going to basically look into all of the circles on our page and adjust each circle according to the data contained within it. So if we do a select all, we actually have circles on the page. They don't have an X position, they don't have a Y position, they don't have a radius. So they're all, if we open this and we hover, they're all at 0, 0, and they're all 0 pixels big. So to actually make these show up, we go through and we say change the CX position, the center X. And in this case, the X corresponds to the scaled X field. So again, the pixel position comes from this scale. So we say for every data point D, pass that field through my scale, and whatever this returns is the X position. Whatever the measure scale returns is the Y position. And in this case, for the radius, we're just returning 2, constant. And there's some other code here, which basically is a switch case statement to change the color. So in this case, we're making entire home and apartments red. If you're only renting out a private room, green, and if you're only renting out a shared room, blue. So this is gonna be what gives us our colors, and again, only 157 pixels. But if we refresh, we actually take the whole space of the web page. We can see here these circles; they're colored. For projector is actually not super crisp, but if you are looking through this on your computer or on the building blocks, you should be able to see a bit of a distribution of colors, but also this spread across as number of reviews scales as the days available. This is actually a slightly different thing, but that is your first D3 visualization. So I wanted to maybe let's take a 10-minute break, go to the bathroom, get some coffee, and work through the exercise. The exercise will be, if you go to this on building blocks, you can click the fork button, and the fork button is going to give you your own copy. So you say, click the fork, it does its magic, and now I have my own copy, which I can remix and adapt here. And the thing that we're actually looking for, I'll show you the solution. The solution has the radius dependent on the, let's see which field, the reviews per month. So scale the radius by reviews per month. Change the opacity to actually have the circles show some overlap. And change what the y-axis is to be price in dollars. So right now we have number of available days per year on the y-axis against number of reviews. So the two things that you need to change to hopefully get you a little bit comfortable with the D3 code is change what's plotted in the y dimension to be the price, and change the radius to not be this constant, but to actually be dependent on the reviews per month. So there's not a whole lot that you need to actually change, but that'll give you a chance to think about the code that's there. And I'll walk around and help folks. So at 3, we'll come back and we'll talk through this. But if you are going through this, try to fork it and make it look like this.
Can you say one more time, y is what? So you said change the y. Radius is based on.
Yeah, the radius is reviews per month. The y is price. Or you can actually make the y whatever you want. So make the y different. In this case, I chose price.
What exactly does forking do? Is that gonna do we have to be logged in to do that, or?
No, so this actually has this idea of anonymous users. So if you do fork, it just creates an anonymous in-browser block that you can then.
Okay, it doesn't necessarily save it anywhere. It just lets us play with it in the
If
browser.
you do want to save it, you can log in with GitHub and actually save it back to your.
So block builder uses the GitHub login credentials.
So if you do want to save your work from this, you can actually fork it and then save it, and it saves it back as a gist.
guys been able to work through some.
So this is actually just going to be the fuel name. Yeah, just for simplicity, you can do price. It doesn't have to be per square foot.
So he said increase opacity and then make the size of the circle depend on the depend on what?
Number of reviews?
Oh,
no,
size.
no, this is number of reviews.
Size depends on number of reviews.
I don't, no, the bottom is number of reviews. I don't remember what he said the size is. Maybe it's in the README for this particular one.
So currently radius is hard for it. So
Yeah, it's just 3.
3. That's probably not the right instruction. Where did it put the instruction?
Under, I just hit the README
Oh,
on the solution page. But I still don't see anywhere where it says size. Well, I'm probably not going to get that far anyway. I'm just going to do basic one. It says price per number of reviews. I thought he did, now I'm kind of confused. I thought he wanted us to do something different. This is, yeah, because now it's a days per year. He wants us to do price. So, let's see. So I think we just switch it up at the top here. Yeah, I think we just change this Y field from availability to Y field. What's that? Let me see here.
Is this also looking for
Huh, what's going on there?
Fields are that.
So do you know what? I'm not too familiar with this interface. Is this highlighted thing? Is that, what is that? That's just a copy of it. Okay. Huh. I guess it's just going, what's going on there? To what?
Why change by field?
Yeah, I know. Yeah, I'm wondering that myself. It looks like this is not code. That's like just some kind of
That's your state.
yeah.
I think this actually does
debugger, maybe if I stop the debugger.
No, also this is you're not talking. It just creates
Yeah, I think that might be why.
and it's all anonymous.
Wait, no, I still can.
Save it fast.
Still won't let me edit this.
What's his name?
Although we said to fork this, did I fork this? Oh, I have to edit this. But then can I run this the same way? Right, so let me see. Can I adjust that? Maybe. Okay. Okay, I think I can edit here. Yeah. Alright. But now can I just run this? Or do I have to... Oh yeah, oh wow. Changes it on the fly? Interesting. Okay, so now I need to change the scale of the axis as well. Oh right, because this is block builder. Right, block builder just puts stuff on the fly, I guess. Alright. Let's see, scale, range, height, max Y. So yeah, so it's going like that. Oh yeah, you're right, there's some up here at 10,000 for the price. That's crazy. Alright, so then
I guess if you hard code that into like maybe
yeah. I mean, what does he have here? Here he has like, looks like he just hard codes it at 500. So yeah, I'll probably just do that then. Let's see, so where is it? Review scale, measure scale. So it's the measure scale as well? Yeah, so max Y. Wait, range. Height 0. Domain. Max Y. Yeah, probably.
That stops it whenever it's
But in its practical way.
they're out.
Okay, yeah. So then I also need to change the size of the circles. I forget what I wanted to change the circles to. Yeah, that's my label at the bottom, which should be a number of reviews. See, x-axis. So that's not where I label it. Let's see. Well, right now, where is search in here for price? There it is. Okay, so y-axis. Add label y-axis. So I want add label to x-axis somewhere around here, right? Let's see. Try label to. So it doesn't have it. Well, there's no label, so I'm just gonna go ahead and copy this. Use this. Label x-axis. And then just looking at the number of years. Didn't quite work out. Maybe because of this stuff, maybe I need to
select the x-axis.
Oh yeah. And maybe I don't want it rotated. What's this? Minus 43? Translate minus 400? I don't know what that is. Did it? Oh, it's here. Okay, number of reviews.
I just like this one.
Okay, then it's there. What's this one doing?
I think we use the slide.
Oh. Let's see it changing anything. Alright, I probably want to change another number then.
translation, you might want to.
Yeah.
Oh, like, because
There we go.
I don't want to do.
Okay. Alright, and then maybe I want another translation dimension as well. Which one switch here? Okay, so that's the dimension I want. So we'll try. Try the other way. Okay, there we go, closer. Alright, that's good enough. Wow, that's crazy. Oh yeah, and it has a slider, that's fine. Alright, nice. Okay, now the size of the circles. So here it's returning 2. But okay, so I can change them like that.
So I increase the opacity, and that will allow me to show the band. So you have 3 items. One is show the overlap, then the size of the circle.
Change the radius, the number of views per month.
Right, that I'm not able to see how to do that because I tried to change it to 7, and I didn't see much difference.
Oh, yeah, so in here, you scroll down to where I changed the circle X and Y.
Oh, see, I see.
Yeah, so in here, the radius is actually hard-coded in the function. So you need to change this to be something that depends on the data. So in here, the reason why the CX and the CY are different for every circle is that they depend on the data element. So in here, you're going to need to not just return a constant, but make it dependent on the data element.
So what is this radius increase?
Although it was recorded as like 2 somewhere down
Yeah, so
below.
this one, this is if you want to make all of the circle within radius and have it be something that you can
Yeah, I don't know if that makes
change.
sense.
Right now, it's actually an unused variable.
Oh, it is because we are
Yeah.
setting it in the function.
Mhm.
Okay, and what was the third thing?
Change the y-axis.
So that didn't work. Is that,
In
does that
this
have to be
case,
commented out on a
The
Excel line to
label's
comment out
actually
the
correct
rest
in
of the
here,
line?
but the data, if you scroll to the top, the data is not. The data, it's not actually plotting the price. You scroll, it's actually plotting
No, it's broken.
the number coming in, or the availability.
Oh, yeah. Oh, the label.
Okay. Oh, maybe that was what was missing before. Okay.
Was there another radius field?
Oh,
Yeah, it was down below that it changed
Do
this.
this, just do price.
But I'm not even sure, I mean, this is a string, right? Like,
Yeah.
is it, there must be something else that we need to like plug it in as like some field.
Hey everyone, I'm going to talk through the solution and then go
Data
through
dynamics field.
the last example. It's going to go through a little bit more interesting things with some interactivity. So this actually gets you, if you've understood things up until the point so far, this can get you pretty far. Right now we've only really seen a scatter plot or a bubble plot, which might seem like, oh, we just spent like an hour and a half and we like got a scatter plot. I could like do this in Excel. The great thing about this, so to help encourage and motivate you is that one, this is all web accessible. It's all in HTML, SVG, JavaScript. You can basically style it with CSS. Anyone with a browser can see these things. You can incorporate it into any other web page. So if you do have a web page that's maybe talking about Airbnb, whatever, propositions, there was a big issue in this recent election. Every one of you has probably seen those Airbnb ads that are a little bit volatile. But again, you can imagine this being part of a larger story, a larger narrative. So you might want to embed this somewhere. And then the last thing about kind of the power of this, of what we've done, even though it's simple, D3 is super flexible in the data and the format can stay the same, and you can just tweak visual elements. So in this case, we can change circles and we can actually make them rectangles. Actually, that's gonna, yeah, let's make them rectangles. So in this case, maybe we're like, oh, circles aren't the best. Let's make some rectangles, or a simpler thing. So rectangles are actually going to do some weird things. But maybe in here we want to do something and we say, all right, let's change the x and the y axis. So in here, they depend on x field and y field variables. So since we want this to be pretty modular and easy to change, we actually set up these variables at the start. So if we do want y to be price, we set it price. If we want y to be reviews per month, we can set reviews per month to be the y, and we can set the size to be the price. Did not like that.
You provide a poster of the previous change.
And you missed a quote on circle.
Circle.
Circle. Awesome. I wish all of you were here whenever I do any D3. So here we change things. We can see that there's some weird correlations. We can hopefully interactively kind of just adapt and manipulate things. DataViz is this very iterative process. So having the flexibility to change what your x represents, what your y represents, what your radius represents, what any of these other things represent, and just have it change in front of your eyes is pretty powerful. If we want to change the opacity, we can make them very light. We can make them much more opaque here. We can do all sorts of things in this very adaptive, interactive way. To go through the kind of the solution here. So the things to change, you can make the opacity darker or lighter. So this is using CSS to actually change our visualization. So that's one kind of key function. The second is change the y to correspond to the price, the size to correspond to the reviews per month. So if we change these variable names here, these are going to propagate throughout the code. So if you do remember from when we first walked through the live code, we had x field and y field show up in a few places. The first place they show up in is finding the min and max and the extent. So to make this as modular as possible so that we don't have to hard code in these field names, the review extent just depends on this variable. The max y depends on this y field, so that was one place they showed up. The other place they showed up is when we were actually doing the plotting and the scaling. So here we are going to change our cx by x field, change our cy by y field, and then in this case the radius, to make the radius dependent on each given row, each given data point. All we had to do was change this from hard-coded to be something that depends on the data we got passed in. So again, the way to make each of these visual elements different and dependent on the data is to access this in this function, the D, but again, we could call this anything. We can just say this function is going to actually operate on review. So the names are not hard-coded. They don't always have to be D, but that's the convention. And in this case, we're going to scale the reviews by, if we want to scale them, we can scale them by the size field. If not, the reviews per month is actually a pretty well-behaved field. So we actually get pretty well-behaved things if we don't actually use a scale. The advantage of using the scale is we can set a max radius. So we can say the radius of these circles should never go past 5. But those are kind of the little pieces that we can change. I'm going to talk through the last example and just highlight some of the interesting interactive elements. There's no other exercise, but it is something that hopefully I'd love to see if you do adapt any of these. Shoot me a message and say, hey, look at this. I took that data, I took the visualization, and I made bar plots or a line plot over time of how these things change. The last example that I'm going to talk through is, in this case, it's actually going to be solution 3. Exercise 3. Exercise 3. Yeah, so I'm going to skip through exercise 2. Exercise 2 is a subcomponent of this. Exercise 2 is basically getting this map. And the thing I want to focus on here is, one, the geographic elements, but also this really cool interactive linking. So this is something that really starts to shine with D3. In here, I don't know of any libraries or any pre-baked tools that are going to allow you to easily geographically represent things and also link it to another chart. So this is kind of starting to see some of the unique features of D3. What we have here, just from a high level, we have neighborhoods in San Francisco in our map. These circles correspond to the number of listings in each neighborhood. So in this case, we can see this is the Mission. The Mission actually has a ton of listings. People in the Mission really love Airbnb. Treasure Island, not so much. And this gives us a sense of where are the places in the city where Airbnb listings might have the most impact, where they might disrupt the housing market, or where they might cause issues with people basically renting out their houses for all year, or artificially inflating prices and so forth. So again, always think when you have these, when you have a data set, I always like to have like thought experiments of how could I represent each column in what way with what visual element, and what impact would that have, what effect would that have, what sentence or paragraph in my narrative of words would that be. And you can use things like color. If these were a different color, would it change things? Would it not? Red might have some connotations. Maybe we make them blue, maybe we make them orange. So there's all these little tweaks we can make to add some context, editorialize things a little bit. And in addition, we can do these cool things where we link stuff. So what we have on your right is the number of reviews over time. And kind of the idea behind the number of reviews is it gives some proxy for how active or popular these neighborhoods are. The data itself is only from publicly available things on Airbnb. So Airbnb doesn't have every listing that someone reserved. That's hidden, that's proprietary. What it does have is all the public reviews and comments on a listing. So when I stay at a place and I'm like, oh, that was awesome, I stayed at this great place in the Mission, you should too. We can get that data and we can plot it, and we can see here, there's some correlation between how many listings there are and how active those listings are. But the other interesting things are, there's some big dips in given times of the year. There's other places that have overly active or underly active listings, even though they might have the same raw number. So these two neighborhoods have somewhat similar numbers of listings, but one is much or slightly more active. We can see here and look at how active they are per the number of listings. We can see trends. We can do a lot of kind of like interesting digging now that we have this visualization, now that we have this tool. And the key things that I'm going to focus on are the interaction and some of the geographic elements. In here, the geographic elements aren't actually super different than what we've seen before. You think of a map as basically a scatter plot on latitude and longitude. If we blow past this debugger, again, a map, the x is actually going to be our longitude, the y is going to be our latitude. So everything that we've already done, we can apply to our map. The difference is that instead of using these scales, these extents, we're going to use D3's geo functions here. And just like with scales, we have linear scales. In D3, to make a map, we have these things called projections. So we say D3.geo, I want to make a Mercator projection, which can be thought of as a geographic scale. And the center and scale here just basically tell D3 where to focus the map. This, in theory, could be a map of the world, it could be a map of the United States, it could be a map of multiple cities. So we basically say center it at this latitude and longitude, and zoom in to a scale of 230,000. So here, these are just numbers you have to play with a little bit to just keep adapting and see where things go. The translate here, this actually takes the map and it can move it on the page. The path here is something that's analogous to the circles we drew. So instead of having circles as our shape, since the map has squiggly neighborhood boundaries, we actually have a path. So we say create a D3 path. In this case, it's actually a geo path, geo.path, and use this projection, use this scaling. And that's how we get the neighborhood outlines. So in here, I'm gonna stop right after we draw that. So we can see here, with just those two functions, we actually get neighborhood boundaries.
Are you drawing the map every time it's loaded on the client side?
Mm-hmm.
So that there are other ways to do that on the server side?
To like pre-render it?
Yeah.
Yeah, there's ways to pre-render any of the D3 on the server side using like Node.js. And again, the D3-ness of it is just a way to generate SVG. So if we look at our elements, we basically have this map with path elements. And you can just as easily do this on the server if it is something that's going to have a lot of data and a lot of computation. So the map, think of it as, a scatter plot with squiggly lines. The second component of what we need to do is actually plot these circles. So I'm gonna jump down to this next kind of pattern in D3. The unique thing about multiple charts, about a map that has data on it, about a line chart that's linked to a map, is that you need potentially multiple data sets. I need a data set that corresponds to the outlines of my neighborhoods. I need a data set that corresponds to the listings per neighborhood. Maybe I have another data set that corresponds to reviews over time. So there's potentially multiple data sets that we have to work with. Each one of them, we can actually use the same D3 functions to load, but they're nested in this case. So this D3.json loads JSON from a URL. The difference about this one is that we're already in the previous map loading callback. So we have our initial callback, which has this thing called geodata. We still have all of our geodata, which is this JSON representation of the map. And even while we're in this callback, we're gonna call another data load, and if we pause it right after, we now not only have geodata, but we also have the data of the listings. So in this case, we also have all of the listings data. To put these bubbles on the map, nothing we have to really be afraid of. We do the same that we did with scatter plot. Attribute class bubble, select circles, but in this case, we're actually using the geodata's features to plot these in the right neighborhoods. Because we do want to plot these circles in the neighborhood. So we need to go to the geodata to actually plot the circle at the right latitude and longitude. In here, we are just scaling things. In this case, showing a different scale. We're using an exponential scale, which is one of the powerful things about all these utility functions is D3 has already gone through the trouble of creating exponential, logarithmic, quadratic, polynomial types of scaling. So in this case, a 1 unit difference in the input corresponds to a 1 to the 1.2 difference in the output.
Are all of this being done inside the JSON call?
Mm-hmm.
It's very different.
It's what?
It's very different from
Oh, yeah. So this is, at the bottom, we have our first D3.json, which loads our neighborhoods. That calls draw. Draw is the top function that we're in here. Way at the top. So draw first draws the map. While we're still in this draw callback, we have a second one where we say, now get the listings data. This is what's gonna draw these bubbles and these circles. And the third thing that I'll go over in the time left is actually the interaction. So you all have enough with what I've shown in the first part, with what you did with the block builder, changing things up, to understand the code that's in there. So definitely go and look at the code. If you have questions, ask me on the Gitter, tweet at me. But the last really powerful thing about D3 is this linking, this interaction. Again, we need to draw this time series. So we have a third data loading. We have D3.csv. So now we're 3 callbacks nested. You can do this ad infinitum. But the unique thing here is, again, we're doing the same thing. We're setting our scales for our X and our Y. We're appending things to the page. In this case, the interaction comes from these functions that are way at the bottom. I'll talk about these functions and then explain how we got here. In this case, any object, we can attach event handlers, which are very similar to any JavaScript event handler, which are very similar to jQuery event handlers. And in here we say map. So whenever we have our map, we save it in a variable. Whenever we mouse over an element on the map, call this mover, mouse over function, and call this mout, mouse out function. We can do the same thing for our circles, for our bubbles. And all that the mover and mout functions do, they basically redraw the elements on our page that we need to redraw. So in here, when we mouse over a given neighborhood, we have access to the data. So in here we have this D element. So just like the functions, all the accessor functions we've seen, we mouse over a neighborhood, we have access to the data element of that neighborhood. And In this case, we're just doing this thing where we change the background to black. So we say, select this element and change its style. And to actually update the line chart, we just say, redraw our line. This draw chart is a function that just draws that line chart. And we say, redraw that line chart for this neighborhood's data. So we can actually go into the draw chart function and look, and it's the same code that we would need to draw a single chart. But now we have it interactively where we hover, we kick off a different draw function, and we adapt the styles. And that's the first bits of doing things in D3 that you can't do easily with many other technologies. We're running up at the end of time, but I will be hanging out outside if you do want to go through and ask me questions about this code, about your own code. I'll still be actively on the Gitter, so if you do have questions, definitely go to the Gitter here. So that's the chat room. The GitHub is interactive data viz. That's where all the code is, and the code is also on those blocks. So if you do want to play around, remix, adapt, go to Block Builder, go to my gists, and again, I'm Jonathan Dinu. Teach a bunch at Galvanize. If you are interested in learning more, getting a deep dive, definitely check us out. Ask me about our programs or workshops. I try to get out and do as many workshops and events as I can around all these technologies. And at Clear Spandex and Hopeless Optimism, if you do want to just keep up with things I'm doing, I always like to post stuff when I create a new workshop or create a new visualization. So I usually tweet news out. And thank you all for being here. Hopefully you feel comfortable enough to start embarking on your own D3 adventures. And I'll be chilling outside to answer questions, to talk to you, to hear about cool things you're working on, and just to hang out. With that, I will leave it to the next speaker.